Okay, in this video, we will find eigenvalues and eigenvectors of the given matrix. And so what we do to determine eigenvalues is say, okay, we do 5 minus r, and then we do 1 minus r. This diagonal, we go 5 minus r, 1 minus r, and a 3 remains the same, and negative 1 remains the same. And so this, we would say 5 minus r. This, we would say 1 minus r. And these two, we keep the same. And we say that this is equal to 0. Next, we will multiply this by this. And we would get, so let me just write it out. So we would say 5 minus r times 1 minus r minus parentheses 3 minus 1 like this is equal to 0. And so we multiply it out. So 5 times 1 is 5. 5 times negative r is minus 5r minus r. So negative r times 1 is minus r plus r squared, because negative r times negative r would give us r squared. And minus 3 times negative 1 would be plus 3 is equal to 0. We can group this and say r squared minus 6r plus 8 is equal to 0. And next we can factor this out. And so we would get r minus 2 times r minus 4 is equal to 0, because negative 2 times negative 4 is 8. Negative 4r minus 2r is negative 6r. And so by doing this, we're getting the eigenvalue. So r is equal to 2 or r is equal to 4 is our eigenvalue. So this is what we wanted. We wanted the eigenvalue. And next, we are going to get the eigenvector. So let me scroll down. And so we'll get the eigenvector when we have for r is equal to 2. So we can write, let me just separate it a little bit. Say for r is equal to 2. If r is equal to 2, our original, what we wrote was this. So 5 minus r. And so what we do here is just plug in r is equal to 2. And by doing that, we get 5 minus r, so 5 minus 2, so 3. 1 minus r, so 1 minus 2, so negative 1. So 3 and then negative 1, and everything else would remain the same. So let's do that. And so like we just did, we said it would be 3, 3, negative 1, negative 1. And next we would do row reduced echelon form. And we can do that by eliminating one of these lines. So this is R1 and this is R2. So if we say that R2 is equal to R2 minus R1, we will eliminate this line. And so we would get, so R1 would remain the same, and R2 would be 3 minus 3, so that's going to be 0. Negative 1 minus minus 1, so that's also going to be 0. And so we're almost there. And so we can say that 3v1 is equal to minus parentheses this, minus v2. Like this. Therefore, 3v1 is equal to v2. And so if we were to say, for example, v1 is equal to 1, so we're plugging in 1 here. Therefore, v2 is 3. And so this occurs with for eigenvalue of r is equal to 2. So this is one eigenvector for eigenvalue of r is equal to 2. So I'll box this one. But we have another one since we had two eigenvalues. And just a recap before we get the second eigenvector, let's look at what we originally had. So we originally said that the eigenvalue was r is equal to 2 or r is equal to 4. And so we already did r is equal to 2. And so now we're going to do r is equal to 4. So the eigenvalue that we will test is r is equal to 4. And we will plug it in. So we'll plug 4 in here. So 5 minus 4 is 1. 3 remains the same. Negative 1 remains the same. 1 minus 4 would be negative 3. So let's do it. So we will say for r is equal to 4, and we would have 1, 3, minus 1, minus 3, and we will do the row reduced echelon form, and we can do that by saying that r2 is equal to r2 minus 3r1, and so by doing that we would get 1 minus 1. First line remains the same, and we would have r2, so 3 minus 3 times 1, so that's going to be 0. Negative 3 minus 3 times negative 1, so that would also be 0. And so therefore we will say that v1 is equal to minus parentheses minus v2. And so that is v1 is equal to v2. And so we could say that the eigenvector would be 1, 1, because if v2 is 1, then v1 is also 1, or if v1 is 1, then v2 would also be 1. And so we can say, just to be formal, is an eigenvector associated with eigenvalue r is equal to 4. And that's all we need to do for this problem.